heard some splendidly well-organized and well-thought-through talks. Well, get over that because I'm simply going to react to some of the things that I heard this morning. Uh, I think this is probably one of the most thought-provoking sessions that I have attended in a long time. So, Moshe, congratulations for pulling such good quality people together. So these are simply little spot one-liners. I hope it won't take a half an hour, and you can either take a break or we can have more discussion. The first observation I would make is that sometimes we use the wrong metrics to try to understand what's going on. And as an example, we might say that we're trying to preserve the old jobs. I mean, here's our numbers. These jobs are going away. This is a disaster. We need to push those numbers back up. Of course, the real issue here is that we need to create new jobs because we're forced into that, and we have to educate people so they can do them. And so we should be cautious about which metrics we use to decide what the state of affairs is. One thing that David Nordfors and I have learned from the Innovation for Jobs program, this is a thing that's been going on for several years. We put small groups like this together, and we spend a day or two talking about innovation and jobs and how the two are interacting with each other. But one thing that we learned very quickly was that the model of school, work, retire doesn't work anymore. And one of the reasons that it doesn't work anymore is some people are living a lot longer. In fact, most people are living longer, except for some of the ones that we heard statistics about, which is quite alarming. But given that you might live to age 100, you may very well have to learn, work, because things will change over a course of an 80-year career. And if you don't learn anything new, it's hard to stay relevant. So this question of how do we learn and how do we mix that with work, I think is going to be very important. We spent a substantial amount of our time today talking about artificial intelligence, and I would like to, and we alarmed by it in many respects. I'm actually less alarmed by AI than I am by another phenomenon which is related, and that's autonomous software. That's software that we put in boxes and we turn loose and allow to make decisions, regardless of whether it used machine learning or other AI methods at all. It's the autonomy that is what is of concern to me. And why is it that I'm so concerned about that? Well, for one thing, we haven't learned how to make software that doesn't have bugs. We've had 80 years or so to try to do this, and we have failed completely. The consequence of that is when we turn autonomy over to these pieces of software, we will experience the bugs. In some cases, they're innocuous. In other cases, they're very serious. And so we should be very, very concerned about turning autonomy over to software regardless of its nature. So we should care a great deal about safety and the software-based systems that we build and rely upon. We should be similarly worried about security, especially if those pieces of software are invaded and are made to do things that were not intended, that are harmful to us or our society. And we should be concerned about privacy as well. So these are all metrics that should be of real concern, especially to the people who are part of CRA, because that's our stuff that we're relying on and that other people's are relying on. Now, as I listen to comments about how we've shifted from a person offering you service to a computer offering you service, a very recent experience came to mind that I wanted to share with you. Some years ago, my wife bought an early iPhone, and she got telephone service from AT&T. But I work at Google, and Google makes Android devices, and I was given a Pixel 2. Well, I already had a Pixel, so I offered to give my wife the Pixel. And she said, fine, but I don't know how to use it, and can you please set it up? So I set about to transfer the telephone number and the accounts from the iPhone at AT&T to a Google Pixel running Google Fi. And to my complete and total astonishment, I could do this completely automatically in about 10 minutes. There was no human intervention at all. One of the reasons it worked is that the Google Pixel did not require a SIM chip. you simply transferred the data over into the phone itself. So this is not intended to be a commercial for Pixel, even if it sounds like it. I apologize if you're receiving it that way. I was frankly astonished that I could do this automatically in 10 minutes. I mean, I was just completely astonished by that. But it tells you that at least under some conditions, some of the automation can be pretty dramatic in terms of convenience. One of the things that David and I and the others who participate in I4J have learned is that people are not necessarily always looking for work that is remunerating. They're looking for meaningful work. Work, especially meaningful work, is what gives you a sense of self-value. And it's the absence of work and the feeling of worthlessness that is so devastating. And that's why some of the comments and statistics that we were seeing feel very compelling, which says that in the society that we live in, we should be working hard to find ways for people to feel that their efforts and work is worthwhile and that they are contributing to the society that they're in. Again, I'm saying these are little one-liners here. Here's another one. I think that as software people, as producers of software or as producers of people who produce software, we have something like a half a dozen really fundamental things to teach people to worry about. Safety, security, and privacy I've already mentioned. Reliability. Why would anybody want to rely on something if it wasn't reliable? I mean, I don't want an automated house that works 97% of the time. I certainly don't want a toilet that only flushes 95% of the time. So this concern about reliability is important, but so is sustainability and interoperability, because as we get a proliferation of devices with software in them, they don't all work together. What you have is a recipe for a nightmare. And by the way, the concern about all those things drives us towards ethics and teaching people who write software to feel heavy responsibility for the way that software works and how it functions in the real world. I made another little note here to myself, and that's the central role of electrical power. And as we talk about anything related to software, we recognize that computers don't run without electricity. It's astonishing how much of our society is fundamentally resting on the ability to get power, whether it's battery power or generated power in the wall, municipal power, or the generator in the backyard. I wear 2 hearing aids that cost $4,000 and they're worthless if I don't have these teeny weeny little 1.4 volt batteries. So if somebody ever decides not to make batteries in that format anymore, my investment is wasted. You should just put that in the back of your mind and think about how dependent we are on this and how important it's going to be to make sure that that electrical power is available to us. We heard, at least tangentially, about the kinds of information and misinformation that's flowing through our society, much of it propagated thanks to online systems, the internet, the World Wide Web, Facebook, and so on. I think that I take away from that the one task that we have that we aren't fulfilling is teaching children and ourselves how to think critically about the information that we receive. Much of what's happened in the last couple of years is a consequence of people not thinking about where did this data come from? Was it motivated? Was it who provided it? What motivations did they have for providing it to you? What's the basis? Is there any corroboration? Critical thinking is probably the most important gift that we can leave our children, and perhaps the most important practice that we can adopt ourselves. Americans don't do enough of that. We don't think enough, and we should be ashamed of ourselves. There's another issue here, and it's related to false dichotomies in general. We often end up having debates about policy by setting up a dichotomy and saying you have to choose this or that. I am worried that an awful lot of these debates are based on false dichotomies. Let me give you an example. It could be wrong, but it struck me as I was listening to the self-driving cars and trucks means that there won't be any drivers. But I want you to think for a minute about what those drivers do in addition to driving. Because when they get to the destination, they also do things, and it isn't clear whether the self-driving car can do the other things that the driver does. And so it's just not clear to me 100% that just because the truck can drive itself that the driver or the participant in that service is necessarily out of the picture. So let's be really careful. Let's think hard about the dichotomies that were offered before we accept them. I think I just have a couple more. There's the graphs that show that college employment was more resistant to automation and that, it made more money and everything else. I had this frisson up and down my back thinking, I wonder if there is a post hoc ergo propter hoc character to that argument. Let me explain why. A lot of companies today prefer to hire college graduates, even if they didn't need a college graduate to do the work. And so we're seeing, I think, a kind of a biasing effect just on the basis of companies thinking that, well, I should just hire college graduates because they're better educated, and therefore. In fact, some of us in the National Science Board, which oversees the National Science Foundation, went to Louisiana to look at the LIGO system. This is the laser interferometer for looking for gravity waves. There are 3 of them, NSF built 2, one in Louisiana and one in Hanford, Washington. Well, we went there to look at the equipment and see what they'd done. They discovered, colliding black holes and colliding neutron stars. But we also went to a community college. And that was a real eye-opener for me. This is a 2-year college. This one of the classes that's being taught is aviation engineering. The guy says 100% of his graduates are hired, and most of them get job invitations before they finish the class. Now, he's actually pretty careful about what he does. He doesn't let you in unless you meet certain criteria. I mean, you have to be able to do basic math and a few other things. So he's being careful about that. But the point I want to make is that in the 2-year period, these people became quite qualified for very well-paid work. And the point is that the 2-year thing might be perfectly adequate as long as you realize that later, a couple of years later, maybe 3 years later, you have to go back and learn some more. How you do that is an open question. Look at what Georgia Tech has been doing with their online master's program, which costs, $5,000 instead of $40,000. A lot of success is starting to show up there. Still, you have to do some metrics to find out how well that's working out. But this idea of finding ways to learn while you're working may turn out to be one of the key elements of our future careers because of the longevity that those careers exhibit. So I think the last point I want to make, I would prefer to end on a positive note, but I confess it just happens that the last one is not so positive, and that is, are we really understanding the power of technology as we talk about all these things, as we create more and more, or are we just senselessly relying on technology in spite of the risks? And so I confess to you, as a person who's believed in technology for most of his career, that I'm starting to get a little worried about, sort of worshiping at the altar of technology. I think we need to ask ourselves, are we sure we know what we're doing here? Do we have the right metrics and values? Maybe we should just step back for a minute. I'm a big fan of technology, but I think that we should be very thoughtful about how we use it and how much we depend on it, and how careful we are to design systems that are resilient in the face of uncertainty. The one thing that I keep hearing in this conference is we don't really know what's going to happen. As an engineer, my first thought when I'm faced with a lot of uncertainty is to design a system that's very flexible, that's adaptable, that can consume and ingest new technologies, that is very open to new ideas and applications. Does this sound a little bit like internet to you? It sweeps in new underlying communication technologies. It doesn't know what the packets are carrying. You can build new applications and the net doesn't care. The whole point here, and of course there's thousands of different organizations running internet, and they have different business models, and it's okay. The internet doesn't care. And so this notion of designing resilient systems, it seems to me, ought to be central to our thinking about confronting the uncertainty of the future. Thank you.
Thank you for leaving plenty of time for Q&A. Yeah, go back there, yes.
I hate Q&A because it assumes I have answers.
Not,
Okay,
not,
all
not
right.
necessarily. Bob Cohen, Economic Strategy Institute. There was a conference like this one in Toronto for economists on AI and jobs. And one of the comments that was made there by Vinod Khosla was that we can't look at the data from the past because this is what's happening is kind of completely
Completely
different.
new and different?
Right.
You know, I'm not so sure that's true. I mean, you know what I wonder sometimes? You remember the longbow? This was an invention, right? Before that, you had to get pretty close to the other guy if you're going to have a battle or something. And then these guys come along with a big, long 6-foot or whatever it was bow, capable of shooting, tens of yards or 100 yards or something like that. And suddenly it was a standoff battle. And I imagined, what were they thinking at the time? I mean, oh my God, it's the end of the world. It's like the atomic bomb has just been invented. The other thing that reminds me of our reactions to new technology. Have you seen photographs from around the 1900s where a car is driving down the street and there's some guy with a red flag in front of the car to warn everybody that there is this thing coming down the street? It reminded me of the police officer that's driving along with the self-driving car. So, that reminds me about self-driving cars. We haven't gotten too accustomed to self-driving cars yet, right? And so we have a bunch of habits that we have learned about crossing the street, which is like catch the eye of the driver. What driver? So maybe we should have robots sitting in what used to be the driver's seat whose eye you can catch, and it can nod and say, yes, it knows that you're there, and you have a cue that says, it's okay, the car knows you're there, you can cross the street. I don't know. We're going to have to relearn a bunch of cues, social cues about that. Okay, sorry. Blather. Here's one.
Edgeridge and Rice University's Baker Institute. Just extrapolating, you made a reference to critical thinking.
Yes.
Is there an inherent tension between AI, social media, immediate data retrieval that works against critical thinking?
Yes, there is, and I'm going to quote Kissinger. I had lunch with Dr. Kissinger several years ago, and as we sat down to lunch, the first thing he said to me was he hates the internet. I thought, well, I guess that lunch is over now. Go on. And I said, well, why is that, Dr. Kissinger? And he said, well, people are satisfied with 2 paragraphs of answer, and I write 700-page books. And, his point is related to what you're asking, because to plow through a 700-page book requires a certain amount of effort. You have to be willing to spend time absorbing and thinking about that material. We are creating a society that is instantaneously satisfied with too little and sometimes the wrong thing, particularly if it happens to resonate with the way you feel today as opposed to the way you should be thinking. This is David Nordfor's I4J. Hello, David.
Hello, Vint. So here's a provocative one. Do you think that with all this that's happening, we're getting more connected? Are we heading for collective intelligence or collective neurosis? And how can we choose the one or the other way?
Wow. There are people who will come and ask me, will the internet wake up one day? Because it has, all those computers on it, and one day they'll all decide that they're conscious. I don't think that we can say exactly where we're headed. The future should not be dictated by machines. The future should be dictated by thinking people. And so if you don't feel a responsibility walking out of this room to think about what the future should look like and what you can do to shape it, you should be. And so I don't think that we're headed for collective neurosis, at least I hope not. But we could get there by making a lot of bad decisions and relying on a lot of bad software to do things that we should be thinking our way through first. I think I'm just going to give you back 6 minutes, which is not so much for that theory.
Vint.
Oh God, this is my old boss, Alfred. Okay.
So Vint, your thoughts, of course, span the positive to the negative, and we're in conflict, which I suspect they are in many of our minds. So on the one hand, all of us say, boy, there's an awful lot of innovation, and it's happening quickly. Do we understand what's happening? Do we have to proceed along these lines? It's a bit scary. We're like the rest of the public in some way. and others of us must adulate the innovation which so many of us in the computing industry have been part of, in academia and the industry. We've really done everything. You sort of said, I wonder if we're marching forward. I don't think we can have a collective non-innovation pact
Correct.
that will work. On the other hand, computing technology, I think by any metric that I know, is 1 million times better in every way than when I was a student in the 1970s. And the only thing that's 1 million times better in every way that is sort of like that are hydrogen bombs, or worse perhaps in that case.
Wow.
But,
Terrific.
we measure hydrogen bombs in megatons, right? And we used to measure TNT in tons. And the same thing's true with this sort of millionfold increase in computing, which is what's happened. So I think what I hear from you is we're not going to have the non-innovation pact. My question to Ed was the similar one about do we understand these systems? Can we build resilient systems? I do think that there is an ethical obligation to all of us in this room, whether in the policy side or in the technology side, to devote a very significant amount of effort to seeing that these technologies that we're producing and their uses, whether in finance or whether in automation or cars, actually have the minimal number of undesired consequences. But there's no way we should stop this, because it's impossible to do. It's a ridiculous thought.
Well,
try to do that.
Alfred, I hope you didn't interpret anything I said as being anti-innovation, because I'm not arguing that.
I thought maybe someone would, because you did sort of say we have to be careful about it's all going so fast.
No, I didn't
we
even
have to
say.
think about it.
I didn't say it was all going so fast. In fact, I think that's a relative thing. If you were growing up in 1900 and you were watching airplanes taking off, automobiles showing up, Einstein blowing up Newton, and so on, you'd probably have a similar kind of feeling. No, what I am saying, though, is that we should be thoughtful about how we apply these technologies for exactly the reason you point out. They're 1 million times more powerful than they were 40 years ago. What is interesting is that you can do some positive things 1 million times better than you could, and things you could never even have done. Example, this morning there was that accident on the road coming in, and I was running Google Maps, and it said we found a better way to go. And I was thinking a little bit about, okay, how the hell did it do that? And the answer is it was getting information from all the other cars that were using that service about how fast or slowly they were going. It was calculating simultaneously all the different, reasonable routes that I could take. And it was doing that for I don't know how many hundreds of thousands or millions of people at the same time. And it told me, we have a better alternative for you. I could not possibly have figured that out myself because I can only see 300 yards down the road. It can see all the way to the destination I was trying to get to on all the alternate paths. I've been given new vision by a computer that has better senses than I do.
So now you finished on a positive note.
Yes, thank you very much, boss.
I'll take the last question. Is software too cheap? And what I mean by that is there is one thing that it's very clear about software, and that's the features, what it does for you. But there are certain other things that resiliency, reliability, privacy, security, these are all very, very difficult to measure. And so when we look at software, there is I compare it to market externalities. I mean, the same way that economists talk about, when we drive a car, we don't see the pollution that we are spewing out.
Yeah.
So that's a market externality. And to me, it seems there are many illities of software that are so hard to measure, they're not being really priced. Unless something really bad happens, Intel started investing much more in verification after the floating point division error, when it cost them $500 million.
So actually, the problem is not as invisible as you would think. When we run our data centers, we are monitoring everything from the low-level power all the way up to the state of the applications. We know when we've sent you error messages. We know when we said 404 page not found. We know when a computer is not functioning. Continuous monitoring of a lot of things, not just in the data center, but the traffic of our own, bodily functions and everything. This continuous monitoring is, in fact, a way of measuring what's going on. That way we can tell, are we failing or are we not failing? Are we reliable or are we not? And how reliable are we? So I would argue that the technologies that we're talking about now have the ability to gather quite a bit of data to help us get those measures that we need to understand how well are we doing with this kind of technology. Okay, I think we need to stop and go on to the next one. Thank you very much.
Thank you, Vint, again.